Good morning. This is our team, and we are here to present our forecasting subject, which is what will be the market of driverless cars looks like in the next 15 years in the United States. We studied this topic in lines of interaction of the cars with the travelers, also adoption of the cars and regulations to understand what would be our career focus as engineers. Let's take a look at this infographic to understand why this study is important. On an average, an American citizen spends 30 minutes in commuting from work to home. Also, 11 out of 12 accidents that takes place in United States is due to driver error. That is some bad driving, and it has been proven that machines are better drivers than humans. Also, a lot of testing is being taken place in various United States, and a lot of players are investing in this. We found that to identify what to forecast is the most difficult part because all the existing parameters are found irrelevant. Also, a lot of things are going on in United States politically, socially, and about regulatory restrictions, which are making it more and more uncertain to forecast. Also, since this is a really new domain of automobile industry, there is no historical data which we can rely upon. Going further, we propose to evaluate our performance as people moved to places without a driver, which is our function, at the expense of man hours put in producing, engineering, materials, energy, and space.
Hello everyone, I'm Sharan Kumar. I'm going to speak about the system operator. The purpose is to understand the need of driverless car in future. The system function is to move people from one place to another place without a driver. In the past, this system is used to move people from one place to another place with a driver, but the system was less safer and comfortable. In future, this system is going to be more safer and comfortable and without a driver, so it's a less self-driven system. When it comes to the super system, in the past there was a less focus on the efficiency and the emission, but in future this system is going to be a more energy efficient system. Tendency: reducing the driver involvement. By doing so, we can save a lot of time during travel, but the barrier would be trust towards the machine as a decision maker. Reducing emission and waste. By doing that, we can reduce the pollution and there will be optimal usage of the resources. The barrier would be substituting the old technologies with the new one, which has high cost of development of new infrastructure. The other tendencies are reducing travel time, increasing the number of people traveling, increasing the AI knowledge, increasing safety, increasing comfort, cost reduction. For this study, Google Waymo's testing data has been considered since it comprises 85% of the testing done till date in California. From the graph, it can be seen that the maximum cumulative miles driven for testing is estimated to be 16.8 million miles, and the plateau is forecasted to be towards the end of 2023. By that time, the car will be available for the public use. This S-curve shows the number of cars sold in US over the time, and it can be seen that the plateau is reached at 2040, but there is another S-curve which shows the number of cars registered in USA, and it shows there is a plateau is reached at 2050. From these two curves, it can be concluded that there is enough time for the new technology in the market.
Hi everyone, my name is Eric and I'd like to start with introducing the T's context of the problem. I start with the technological aspect, when the advancement in the hardware and software have opened up the possibility to even consider the driverless cars. However, we still see the quality of the software and the processing power of the hardware as the main barriers. Moving on to the economical aspect, we see the expenses due to the accidents and the travel time as the main drivers. However, the technology introduction costs in terms of different aspects seem to be the main barrier. Moving on, we've seen one borderline social and economical barrier, which is the increasing distance between business districts and the residential areas. Other social barriers include the lack of trust in the AI making the driving decision and the safety regulations, whereas the drivers for the social context include the increasing population size and its standards of living. Lastly, I'd like to touch on the environmental perspective, where the pollution, waste reduction, and increasing traffic seems to be the main drivers. However, the resources required for the introduction of new technology in terms of the CO2 production, for example, seem to be the main barriers. Following this, we have found a number of questions which will help us overcoming the barriers, of which I will only discuss number 1 and number 5 due to limited time. The first question, how to improve road safety without incurring higher cost. This happens during the travel and at the roads. And we see that in the system of driverless car and its features safety, when it's higher, we have safer car. However, we are having higher cost of purchase, which also has to account for the development cost of the driverless car. Hence, our desired result is to have safer car with lower cost on the roads during travel, and this should be achieved with minimum changes to the system. My next question was how to develop new infrastructure with limited investment, and we are now focusing on the modification of the roads during adoption. If the modification is low, we have low modification of the public spaces to accommodate driverless car. However, we have higher investment in the development of the AI, and the opposite happens if the modification is high. Hence, our desired result is to have modified public spaces with least investment possible.
Myself Rakshit, and I'm going to continue from here. To determine criticality, the desired results corresponding to each of the above mentioned contradictions have been quantified by defining its measure. For example, we are measuring car safety by the percentage of cars with accidents. Once all the measures are obtained, they are sorted into 5 different groups, which are performance, cost, social impact, urban space, and technological development. These are critical to X features and they are mapped against our contradictions. By using this, a relationship is drawn between the tendencies and the contradictions that affect them through their values. With the help of these relations, contradictions map is developed using the CMap tools. The contradictions have been arranged based on their hierarchy. In our case, concentration of urban work areas, modification of control system of the cars, and level of driver interaction top the list. With our limited knowledge, the time period to overcome each of these contradictions and for the implementation of new technologies has been estimated and mapped as a roadmap of our forecast. From this roadmap, we infer that it would take 444 months from 2018 to surpass all the contradictions and to achieve the highest level of safety. That is by the year 2055 in the United States.
Let us take a look at the most important features of the next technology to move people to destinations without a driver in the United States of America in the next 15 years. This technology will have low driver interaction and reduced driving time, particularly for long distances. This is based on the tendency to increase comfort of the user. The technology will have high sensing capabilities and high AI integration. The cost of travel per kilometer will reduce as there is more propensity towards energy efficiency and shared transport that is available on demand. Technology will be tested at least for 16.8 million miles to ensure safety. This means that there will be certain changes in the super systems, which include the urban space, which will be highly interconnected, a low fatality rate due to driver errors, social shift towards shared on-demand transportation systems, and an increased social acceptance of driver assist and fully autonomous systems. There shall also be an increased investment towards changing the infrastructure to adapt to this system. In conclusion, we can say that the adoption of the autonomous cars will not begin before 2023. Given a certain safety limit of testing, modification of the urban infrastructure will be necessary. The safety and social acceptance will drive the changes in regulation and infrastructural changes. Currently, California and Nevada are the states which are heading towards this goal.